Okay. So welcome everyone to Breakfast with Birkbeck. Today we have Dale Mineshima-Lowe and Felix Reidl here to talk about the environmental impact of data, AI, digital technologies, and so on. So I'm going to hand over to them to introduce themselves a little bit more, talk about what they do, what they teach. Felix, do you want to start? What do we need to know about you, your research, what you do at Birkbeck?
I'm happy to start. Yeah, so my name is Felix. I'm German by trade. I'm a senior lecturer at the School of Computing and Mathematical Sciences. So I have a computer science background, and I teach data science fundamentals to undergraduate and postgraduate students. My personal research is slightly different. I come from an algorithms background. So that's broadly the study of how quickly we can solve problems with computers and whether we can solve them at all. So it goes kind of in both directions. I'm also the director of the BIDA Institute for Data Science and AI. That's a mouthful. And so I've been involved with discussions around AI since probably 2021, of the inception of the large language models and so on. That's me.
Amazing, thank you. And Dale, what about you?
Hi, everyone. I'm Dale. I'm a full-time lecturer and faculty member of Parama University, which is, I want to say, nominally nominally based in Myanmar, but we teach fully online synchronously. I'm also a visiting lecturer in climate change and environmental hazards on the MSc Global Environment and Sustainability program at Birkbeck that it has. It's a distance learning version of one of the MSCs that we do have in-house as well. In terms of my research, so I'm interested in things like data agency, and I guess that's what brings me towards the AI and sustainability. So it's sort of the crossover and the nexus, I guess, of my interest in environment, but also in terms of governance and digital tech use. And so that's where I'm at. In my research at the moment, I'm looking more towards use of technology for democratic governance, but also environmental and sustainability. Sorry, brain's gone to sleep slightly. Sustainability efforts to engage citizens as well. But that's me.
Sounds amazing. Okay, so start us off. This feels like there's been a lot of focus lately on the environmental footprint of AI, but also it feels like every time that I'm looking at posts about AI on my LinkedIn profile, AI is being used as a shorthand for ChatGPT. So I feel like the first question should be what AI is. Perhaps Felix, you could start us off with this one.
I'm happy to, and this is going to be a slightly longer answer because it's actually quite difficult to nail down. And the reason for that is that artificial intelligence was always more of a marketing term than an actual technology. So this started in the 1950s, where researchers that were kind of, they saw their current field of study, which was mostly called cybernetics and automaton theory and so on. They saw this kind of staling out, right? Like there was no new money coming in. In particular, the American military was not interested anymore of spending too much more money. They've gotten what they thought they could get out of it. So the time was ripe for a new type of, like marketing term, and that was artificial intelligence. It kind of also changed the direction of research slowly because the goal setting was a little bit different. But in the beginning, there was the same thing. There was just cyberneticians, automaton theory people, and statisticians. It was the same people just doing something slightly differently and calling it something different. So already at the inception of artificial intelligence, it was a hodgepodge of different things. It wasn't just a single technology. And we've seen over the decades since the 50s, kind of several iterations of AI technologies with vastly different underlying ideas. Started with kind of symbolic computation and agent-based systems where people thought, well, if we just program the logic of what we see in the real world, how animals behave, how humans make decisions and so on, then at some point, if the program becomes complicated enough, we have something that we'll call intelligence. And that's kind of the time where like expert systems and agent-based systems came about, and they could solve some problems, but they were very far away from what we call like human-like intelligence. And then we had a shift because that kind of stalled out again, and we had a shift in the approach, and it became more statistics-based. So much more on ingesting data, doing something with that in order to train something. And that's kind of what we're still doing today. So that's still the paradigm that they're operating on. But we've seen several iterations again inside of that, starting with very simple statistical models. Neural networks already in the 70s and 80s were a thing, but they're very small scale. They were hard to train. People didn't have the data. And then in the kind of big data revolutions and in the aughts, suddenly data was available. And then we've seen methods that used much, much larger pools of data. Google in particular was very big in that with machine translation. And then in the 2010s, we had the kind of the deep neural network revolution, which meant bigger networks, slightly more complex ideas, much longer training times, impossible previously because computers were simply too slow at that time. And so again, AI changed. So this is probably where the confusion is coming from. AI has been a term for different technologies, and roughly, I think it has settled now on the technology side. It is things that we train in computers. So we train that, we don't program it by hand anymore. We give it a lot of data. We have some kind of training method so that it finds pattern in the data and then produces something. And I want to just, at the very end of this, I know I've been speaking a long while, I just also want to point out that AI now is also not just the technology anymore. When people speak about AI, there's a political program behind that. There's an ideology behind that. There's an economic agenda again behind that. So AI is this really, really fuzzy term that encompasses all of that. And on top of things, it's influenced by our ideas of what computers, like high-tech computers, can do by science fiction. And it's no accident that these companies lend a lot of ideas from science fiction, because they themselves don't have the vocabulary to think about these things yet. So that's what we're seeing. That's why it's so confusing. So if you're confused by AI, you're not alone.
Amazing. Dale, I see you nodding. Do you want to add anything or come in on any of that?
No, I think what Felix is saying is true. I think there's just so many things that get wrapped up as AI. And one of the big ones, obviously, as you mentioned, Aideen, is, ChatGPT and sort of some of the other big learning models at the moment that seem to have infiltrated and kind of embedded themselves in particular in the sort of academic institutions, but I think also for policymaking. And we'll come back to that. But one of the things I find interesting is how governments are starting to think about using and experimenting AI for different things. And we see this in the news on an almost daily basis as well. But I'll stop there and we can kind of pick up on some of that with a few other things.
Sure, we can definitely come back to that. Okay, so moving on to the environmental impacts, and perhaps Dale, you can start us off on this one. How significant are the environmental impacts of this group of technologies? It seems, again, like this is something that we see conflicting reports about in the media. On the one hand, sometimes reports seem to suggest it's quite big. Other times reports seem to say it's not so bad. So what do we actually know about the impact of the environmental impact of these technologies?
I think you've just kind of nailed it in the head, that actually there's a lot of speculation about the carbon footprint of AI and of all these technologies. And part of it is around energy consumption. So, in terms of things, say, and we'll come back to this, a lot of these computer running sort of processes need a lot of storage. So, you're talking, I guess, for me, when I think about the carbon footprint of things like AI and other technologies, it's about where is it stored in terms of the data, where's the processing? And I think that's where some of the issues are running, or at least some of the question marks about how do we measure it, what's being measured, because you can measure pure energy consumption. And so if you think about data services and data centers, how much energy does it use in terms of electricity? A lot of big data centers, for instance, also need a lot of cooling. So how much water? So you're thinking about multiple resources along with land usage. But then it gets more complicated because there's some people who are trying to measure these digital technologies, not just on their usage, but actually from their origins. And that's where it becomes really difficult, because where do you start? Where do you stop? Is it about the way in which we build those buildings that then house those big data centers? Where they're located, but also how they're built. Are they mega ones? Are they sort of mini ones? Because dependent on the construction, that can have an impact on the overall carbon footprint. So it's kind of, I think this is where some of the sort of the speculation, but also some of the difficulties and the challenges are in terms of that environmental footprint. The other thing I want to bring Felix into this, because I think knows more about it, but one of the other things I think that happens with trying to make those estimates is also between what you mentioned about training, Felix, in terms of using these computers and doing training versus what they talk about in sort of digital tech as inference. So how it's being used in terms of the learned knowledge, so that training being put into practice, I guess, or what they call in action, and knowledge to make predictions or draw conclusions. And that has different energy consumptions as well, but also implications about storage on foot. But I don't know if you want to add anything to that, Felix.
Yeah, I think the life cycle question is really interesting, and it's being used to justify AI usage by making these calculations on like, okay, like asking ChatGPT is slightly more expensive than doing a Google query. So the energy consumption is roughly a factor of 10, at least that's the estimate. These companies all keep these things very close to their chest. So it's very difficult to get good numbers on these things. So it is slightly more energy expensive, but people say, oh, it's still just like a few cents of energy for a long query. That's not very much. Of course, neglecting the training cost, which is insane. Like that is something that only the biggest companies currently can achieve in huge data centers that run for months. And you have to imagine it's full of computers, right? It's a huge warehouse full of computers, and with specialized hardware that is very good at doing these types of operations that you need for this learning process. And it's going through probably terabytes, if not more, amounts of data. So it's an insane process. And if you had told me 5 years ago that that's what we're going to do to build AI, I would have thought like that's just not feasible. That's not possible. That's not economical. So these training costs are really, really high. And what people currently say is like, oh yeah, the training costs are high, but we just build this model, then it's there, and then we just use it and kind of compare it to a product that has a high upfront production cost, but then use it for a long while. Like, I don't know, an industrial smelter or something like that. And very difficult to sell up, but then it just runs for a while and you kind of recuperate the energy, the initial setup costs and energy costs. But of course, what they're ignoring is that there's an ongoing race of trying to improve these models and making them bigger and scaling them up. So there's no stopping in training. It just doesn't stop. And I wouldn't be surprised if at some point they move on to a model where the training is constant, because obviously what companies like OpenAI are doing now is they're collecting all of the usage, that the chat protocols that people leave behind by using the system, and training on that. So they gain more and more training data. So I'm pretty sure at some point they will want to try to do the training live in some sense. Like it's not quite live, but like keep on improving the model. And so I don't think training costs can be amortized by saying like we build it once and then we use it, because I don't think that's the reality that we will be living in. They will want to have AI models that kind of can keep up with current affairs. And right now, if you ask a model about things that are happening right now, chances are it will tell you, oh, the cutoff was like, I don't know, a year ago, and I don't know anything about the things that are happening right now. So yeah, I agree. The energy costs seem to be enormous. We have seen like a rough doubling of data centers since 2015, and you have to factor in that was already the time, like kind of the peak of social networks, of Facebook, of Google, of all of these companies were really, really, really data intensive. And we've been doubling that. So that kind of gives you a sense of the scale that is being operated on. And I think it's very difficult. There's the political dimension. I think this is not something that's being discussed very transparently. Right now, there's a data center being built here. I live in Watford, and kind of in Watford, that they're trying to set up a new huge data center. I don't know whether it's one of these gigawatt data centers, as they call them, but it's supposed to be one of these AI things. And I'm a bit worried about the energy consumption in this area and what that means for the grid stability, what it means for water consumption. I assume we have enough water here, but I'm not quite sure that that's always true. So I think there are very real issues that come about with these data centers, and they're not being transparently discussed right now.
Yeah, there's a lot to unpack there. I mean, in my research, I work with climate model outputs quite a bit. And I remember some years ago when the big question was, we're creating all of this data, where is it all going to be stored? And it feels like that just, shrinks in comparison to the scale of what we're discussing. But it does kind of remind me that these tools, cloud computing, big data storage, all of that is stuff that climate researchers use in their work as well. So do we have a situation where these technologies can be both a contributor to the problems and also part of the solution to environmental issues? And if they can be part of a solution, how do we kind of minimize these negatives, like reducing the energy consumption and carbon emissions associated with them?
I think that's like the 50 million pound question there in terms of that. And I guess to really address that, I think with some of the technologies, I mean, we know that the sort of technologies can help to improve some of the climate models, and we're starting to see that. It's able to pull data from different places, and it can reduce the uncertainty in some of the models. We know when we're predicting sort of where we're using it to predict different aspects of climate change, for instance, we're using multiple models. And so in some ways that big computing will be able to help us to take those different models and kind of, in a sense, overlap them in a better, in a more holistic way that might give us a bit more certainty, not full certainty, but a bit more predictability and lower the uncertainty in terms of what we get as results. But the flip side is, as Felix was pointing out, that's a lot of energy consumption that requires constant, sort of 24/7 in order for that to occur, because it's not only collecting data from different places, it's trying to analyze it and kind of recreate the models in a sense to be much more up to date. So there is that ability to kind of help in terms of sustainability, and I think address some of the climate change challenges that we have, but at the same time, alternatively, it's creating that sort of consumption of not just energy, but water. I mean, one of my big things with some of these data centers is where they're placed in the water consumption that is needed for cooling, because with some of the mega ones, you're talking about huge amounts of water. I know I think it's in the US, one of the new data centers they're considering, or is it in the UK, that they're considering putting it next to, it's the UK, next to a new water reservoir that they want to build. That has real implications then for water usage of that area as well. So you build a big reservoir water, great, because you then think that can be used by consumers for, household, etc., businesses. But if you've got a big data center next to it, does that mean it's really being built for data center and actually just drawing in more of the water from actual consumers living and residents living in those areas as well? And we're starting to see this as an issue, not just, I would say, in the, sort of in the US or the UK or Europe, but also I know for me, I look at Southeast Asia, and that's becoming a huge problem in that region of the world as well, where water shortage is already a massive issue. That's adding to it and changing the sort of the land usage and the demographics in terms of where people can live and survive, because of big data centers that are being built to encourage investment in more digital tech as well in some parts of Southeast Asia.
If I can butt in, I have a much stronger answer here, I think, to your question of whether these technologies can help us solve the problems that they're exacerbating. And I think what we need to look at, and here it's very important to take apart the term AI and what we mean by that. If you mean by AI large language models like ChatGPT, I would with almost certainty say no. These technologies will not help us. These are not models that are there to solve highly specific problems like climate simulations and so on. There are AI technologies that maybe we shouldn't call AI technologies anymore because the term has been captured, but there's machine learning models that are very, very helpful in medical imaging, in climate simulations, in other physical simulations, geology, and so on. There are very, very good models that really have improved things like cancer detection and physical simulations, but these are not the same technology as ChatGPT. They are miles apart. They have some similarities in that they are training some kind of network to do a certain task. But ChatGPT and all of these other models, they're more like the everything machine. They're supposed to do everything. And it's a jack of all trades approach. And that's what you see with these models. They're very confident in their output and in their language. But they solve some tasks quite well. I would say everything that is related to language, like reformulate this text or give me a summary of this text, often very, very good. And I've personally, I'm sometimes using it. I try not to, but sometimes I reach for it. But any other task that you throw it that is a bit more complex, a bit more technical, very quickly you'll see these things are not solving things. They give you things that look very, very plausible, but if you have the expertise to check it, you often find mistakes. And they're not there to solve climate change. They're just not going to do that. And I would also like to point out that there's this effect that these AI technologies are replacing other, in my opinion, more suitable technologies to do certain tasks. What I mean by that, take the example of I've caught some of my students use ChatGPT to solve basic mathematical questions. So you put in like, I don't know, some small equation or something like that, just arithmetic, right? You could use a calculator for that, which runs, if you have a very cheap one, runs on solar power or a small battery, uses almost no energy. I often type these things into Google because I'm a little bit lazy. That's already not that good, right? Like you're sending data packages with that information to Google. Some server is picking that up somewhere in a data center. Has to understand that what you're doing there is trying to solve a basic arithmetic question, and then it produces an output for you, right? That's already orders of magnitudes worse than just using a calculator, either on your computer or somewhere else. But now ChatGPT is a whole nother thing, because that thing doesn't do a computation like a computer does. It doesn't understand numbers as kind of bit patterns that can be added together very efficiently in your central processing unit. No, it understands it as language. And so it engages its language model to kind of guess the answer. So you often get an answer that's incorrect if the numbers involved are quite large. It's been getting better at that. But it's like using a Rube Goldberg machine to solve a very, very simple problem. And I think this is what we're seeing, that a lot of simple tasks are being transferred to AI because it comes with a kind of de-skilling of people. Like you don't have to learn how to use, I don't know, Excel or Word, or learn how to do basic programming if you can just throw it into the AI, and often it gives you an okay-ish answer. Or you don't need to learn how to draft an email or plan a meeting if you can just let the AI do that. But now all of the things that didn't cost much energy before, or just the energy of you existing and maybe having your computer running, all of a sudden this has a really, really high energy footprint. And these companies are pushing that on us. Every one of your products now, like WhatsApp now has a chatbot built in. I was surprised to see that. The basic text editor in Windows, Notepad, one of the most low energy consumption programs you can run on your computer, now has an AI integration. Every Word, every Excel, everything is AI now, and it prompts you. It sometimes, without you even doing something, it starts giving you suggestions that is already burning energy that you maybe not even want to burn. So I think there's this dual side of like, not only do these things cost a lot of energy, and we might discuss, well, maybe if we're using it for things that are very important, then that's a good investment of energy. No, we're de-skilling people and upping up our energy for something that shouldn't cost much energy. So I think that you always have to keep that in mind when people do a like back of the envelope calculation saying, oh, it doesn't actually cost that much energy and it doesn't cost that much water, and it's fine. It costs more and more energy and more water because the companies are trying to induce more and more usage of these things. Right?
Yeah, it does feel like it's becoming one of those things, a bit like, leaving a light on or a TV on standby, that individuals maybe feel like it's a small thing, but when it becomes, when everyone is doing it, it starts to scale up quite rapidly. So it sounds like, yeah, lots of sustainability challenges here. Dale, coming back to you, I feel like you would be able to speak a little bit more to the ethical issues that arise as well when this kind of technology is used to address sustainability challenges. I'm thinking here about things like, AI-driven insights into transportation networks or water use systems or something like that, which seems quite paradoxical when you think about it. But what do we need to be aware of in terms of things like privacy, bias, digital divides, as those kinds of technologies are used in that way or could be used in that way?
I think it kind of piggybacks what Felix was just talking about in terms of the constant use, because actually the use of things like ChatGPT, for instance, or even Google, that's kind of feeding back into the system. And it's things that people don't think about on a regular basis. And so for me, one of the interesting things is we're quite data privacy conscious and as people, I think now, but at the same time we're not. And so in some areas of our life, we're very conscious about giving up our data and not giving it up and kind of having control and agency over it. And then in other areas, we don't actually think about the use of things like, someone's asked, using Google, where we just type in questions, or even within things like ChatGPT. So I think there's that level of sort of consciousness and unconsciousness and bias, individual bias in terms of how we see it, and our use of these technologies. I think the other thing that for me is really is quite interesting is with a lot of the big, sort of machine learning, language learning processes, we've got to ask the question about what are they being trained on. It's something I know that's been raised time and time and again, but it is so important because whatever data it's being that's being fed into it to train it will also include biases. And so, it'll be training from data from particular parts of the world, for instance, or it might be excluding particular parts of the world. That has an implication then, because if everyone, it's open and everyone is using it, but yet it's been trained on a sort of very specific pattern, a very specific way of doing things, it very much excludes others. I mean, I want to use ChatGPT as an example. So, the models it uses, it's been using a lot more modeling, obviously, on data that it can get from much more, I would say, Western and global North nations. That has an implication for my students who are using it in Southeast Asia, for instance. Like in terms of the fact that AI detectors will detect all of them as being really high level usage for some form of AI assistance with their writing it might be partially true, but it also will be based on particular language patterns that it's looking for. And if you're learning English as a second or third language, there may be particular language patterns that you are learning yourself as someone being taught that language as a second or third, fourth language. And so I find it really interesting to kind of have to think back in terms of who's creating it, how it's being created and taught in terms of that learning process. So I think there's a lot of ethical questions to ask, and bias is already built into that, but also ethical questions for me in terms of, do we truly have agency over our data? Because sometimes we have to use certain things, and those then that data doesn't, we sort of give up that data willingly, but also sometimes under duress, but we have to in order to be able to use other systems or become access other mechanisms. And that for me is one of the real key ethical issues in terms of sort of data agency as well. It's we can say we own it, but do we really, after a certain point, have much control over it as well?
I
Yeah,
see
that
you
last
nodding,
point.
Felix. Yeah, do you
Yeah,
want to come
that
in?
last point resonates a lot with me. I feel like these systems by their design right now are vastly centralized in private hands. There's no oversight. I mean, our governments have given up regulating technology since, I don't know, the early internet, I think. And it's just a big free fall. And I think this is the next iteration of that. And I think if we don't control what's happening with these models, I think very bad things will happen because of these models. One example that I think really drives this point home is if you're using Google Photos, it has a face detection feature, right? And you can flag like the people that you like and tag them in the pictures. And so it very nicely lets you search for people in your own photos, right? What you're doing there is you're training a face recognition algorithm, right? Because you're telling that here in these pictures, it's the same person. Sorry, my kids are being a little bit noisy. So you train this and say like, these are the same pictures and so on. This is training a face recognition model. And this model is now situated at Google. And it's really good at recognizing the same people in different pictures from different perspectives. And we've all contributed our data to that and a little bit of digital labor, right? We've been doing the flagging and so on. Now, what is happening with this model? If this was just like a consumer product, I wouldn't have much problems with that. But a year ago or so, the New York Times and I think also the Guardian reported that the face detection by Google was now being used in Gaza to categorize people into terrorist or non-terrorist, or feed into the intelligence apparatus. And that's not what I signed up for personally, right? I didn't help with my data and my little bit of labor. I didn't help to train something that's now has military applications. And let's face it, what's being tested in Gaza right now will not stay in Gaza. It will be sold elsewhere to Palantir and who knows what. And these systems will proliferate and come back to haunt us. And I think, and that is just a very relatively simple system that's being trained. Face detection is something that has been solved since like maybe the 2010s or maybe 2015. Like you don't need a huge large language model to do that. So the question is, what is happening with the models that are we currently actively training, that's been trained on all of the data we've been generating, on stolen data really? What is happening with these models in private hands? What are they going to be used for? And I don't think it's going to be a consumer product, because the economic case just isn't there. The business case isn't there. They're making huge losses, right? OpenAI only exists because Microsoft is providing them with huge amounts of free computation. So even a subscription model will not cover these costs. So what will cover these costs? It's going to be military applications. So that's my bleak ethical concern about these models, the lack of control that they mentioned.
I think to connect to that, Felix, it is not, you mentioned about it being in the sort of the hands of, private hands, and then kind of being used for military purposes. Also, really recently in the news, the UK government as well itself, the Justice Department is experimenting with using some of these types of, sort of developed models, face recognition, language models, to try and identify individuals most likely to commit murder. So they're trying to, do a minority report kind of issue, but they're playing with the, sort of the data, and they're playing with the some of the models that have been already created, as you say, kind of unknowingly by the public, using, wanting to use that for our own personal purposes, but that's creating a huge wealth of data for companies to then siphon off, use, but also sell off. Because that's the big issue for me as well, is we don't always get told as consumers how our information is being stored, but who it's being shared and sold to. Because if you have to go all the way into the nitty-gritty details for any app that you're using to really find the details about, one, how does your data actually get used, but also two, can you really clean all of your data off of their systems? Because they would say no, because once they start to amalgamize it and anonymize it, then no, you no longer have ownership of your data. Your data is kind of there for them to be able to use and sell as they wish to third parties.
quite a good reminder that even when it seems like the initial usage might be for one thing, like let's say that there is some sustainability tool developed, you don't quite know where that's going to go in the future or where the underlying technology is going to go. So last question, thinking about something we touched on at the start, the geopolitics of these technologies. Dale, you mentioned this a little bit in terms of there being patterns in terms of where data centers are built or who controls what. How does all of that impact the environmental impact? Does it shift things in terms of where the impacts are felt the most?
I guess I want to use the example there in, again, back to Southeast Asia with data centers. So I'm thinking of places like Singapore have been a huge sort of hub for technology, but also creation of data centers as well. They're finding it's having an impact on their own resources in terms of land usage, but in particular water and electricity. But right over the border in sort of Malaysia for them, there is cheaper land, more resources as far as they're concerned, because it's not Singapore's direct resources, but they can then ship that. And what we're seeing is the movement of incentives to build data centers near but elsewhere, so that it doesn't have an impact on your, say, your local community, but it does on others. So in that particular example, it's moved to Johor, and Johor there is a huge issue where there are resources, land is cheaper, but also at times water becomes very scarce, and much more so in the last decade. And so what we're finding is data centers are being offset in places where they're cheaper to build, but actually not cheaper to run, and has been having a detrimental impact on the local residents and the residents living around there for those resources as well. So there's I know Felix mentioned in terms of your example in Watford that, building that big center, you've got to ask the question about, well, where is it going to get all of its resources in terms of, will it put a strain on, electricity, but also in terms of water usage? And I think that's something that needs to be really addressed. But unfortunately, a lot of governments are sometimes looking at this as a way to create new investors and bring in sort of foreign investment in some countries. So you offer the ability to build mega data centers, for instance, on the back of knowing that perhaps you don't have all the resources, but are kind of hoping some of that investment will help to create those resources in some way. And that doesn't always happen. And so for me, the geopolitics of it is those who can afford it can offset it, and those who can't are being landed with this in their backyards, which is a huge detriment to their communities.
It sounds like a real environmental injustice issue occurring around that. Felix, do you want to add anything before we close?
Well, there's a second angle to geopolitics, I think, and that is, how do these models themselves and the building of these models, how is that currently being used as a political wedge issue? And specifically the animosity of the US against China at the moment. One of the kind of battlegrounds is AI. And so how we now, it used to be in the 90s, it was like the evil chips from Japan, the evil chip makers in Japan, kind of out-competing us and building new military machines and new computers and all of that. So it's a very similar, it echoes kind of this type of history. And I think right now the quote-unquote AI race is the battleground there, this technological battleground. And I think it's used to kind of heighten the panic between Western states and China in particular. So in a really weird way, it's also not just a political actor, but in itself, it's also the object of politics, of geopolitics at the moment. And I think often, I think there's a lot of panic around that, because the AI hype is telling us that these models are so incredibly powerful and dangerous, kind of at the level of nuclear weapons or something like that, right? That's the hype that's being built up. And so if you now say, oh, China is building these things and they're investing so much money and energy in that, and that's why we have to do this, that's just the nuclear arms race again, right? The same logic applies here. With the difference that nuclear weapons actually are very, very scary and powerful, whereas I don't actually think that these AI models are as scary as people make them out to be. I think they can be useful. I think they have the use cases. Also, I come off as very technologically negative in these. I actually think there's a lot about the approaches that led to LLMs that are super interesting and that could be very beneficial to everyone if we had a say in what's going to happen with these models and what they're built for and what their purpose is. But instead, these big companies are trying to build like the machine god that solves everything, becomes general artificial intelligence, becomes overpowered, which I don't think these people really believe that they're doing that. I think that's just the selling point for why they need more and more investment. What's happening here is just they suck up all of the technological investments. They suck up the energy, the resources. It's a big kind of centralizing push to make the people that are already very wealthy even more wealthy. And I think that goes back to what Dale is saying. That comes with all of the usual kind of neo-imperial moves of building the things as cheaply as possible, as dirty as possible, in locations where people can't push back against these technologies. I just want to add one thing, because Dale had kept on mentioning water consumption. And this is such a big point of contention online, and I find this so interesting. Every time someone brings up the water consumption of LLMs and data centers, people say, oh, but they have a closed cooling loop, right? The water is just recycled. And it's somewhat true. A cooling loop that is water or some other liquid being recycled inside of the data center. And it is also true you could build a data center that then uses the air, like big radiators essentially, to get rid of the excess heat. But that is vastly expensive. It's much cheaper just to take drinking water, heat that up, and put it back into where it came from. And that's what companies are doing because it's cheap and they're allowed to do it. So again, just because we have the technology to do something in a sustainable way doesn't mean it's being used that way. And it's often being used as a shield to say, like, oh, of course they could be powered by solar power, but they're not. Grok is being built in Memphis, in a poor area of the city, by running big petrol generators 24/7. So it's not, it's the absolute opposite of sustainability. So I think my final word on this is, like, we have to be very careful just because people trot out technology as solutions, even if it's technically possible to implement these solutions. If the political will isn't there to force companies to do that, then private companies will never implement something that's slightly more expensive and better for the environment. It just doesn't happen.
Can I just add something to that, Aideen?
Go for it. Yeah.
I think really, really interesting. I think you're right, Felix, because I think part of that kind of comes back to that issue you were mentioning about the politicization of it. It becomes a competition and it's labeled as a national security issue by states. And so it's sort of interesting because then states don't necessarily want the responsibility of paying for these things. And so they then offset it by allowing private individuals to control it. And so you have this real dichotomy where, kind of like you said, Felix, with the, sort of the Cold War and sort of the nuclear armament, you have this buildup, but actually it's not always even within people's own countries. They're kind of then starting to use, third country sort of parties to kind of help to support that national interest as well. And that's where, in terms of the global order, weaker countries will have less agency to really make a difference. And that's quite detrimental to them as well and their people.
Okay, thank you so much for this, really insightful discussion. At times scary, but always insightful discussion. So thank you, Dale and Felix. We're going to move on to questions from our participants now.